Welcome to Engineering Out Loud, the second episode of our series from MECHESOL's MESP Engineering Development Program titled Design Tools. We're diving into the software that helps engineers create amazing things, So don't forget to apply to this awesome program at mechesolco.com/CPD.
Yeah, it's like having a superpower. You start with an idea, and then boom, you can design it, test it, and even figure out how to manufacture it all digitally.
Okay, so you got me hooked.
Yeah.
Let's break this down. What are the key tools in this digital toolbox?
We've got three big players, CAD, CAE, and CAM. They work together to take your idea from concept to reality.
All right, let's start with CAD. What's the deal with that?
CAD stands for computer-aided design. Think of it like a digital drafting board on steroids. Programs like AutoCAD and SolidWorks let engineers create precise 2D and 3D models of their designs.
So instead of sketching on paper, you're building with virtual parts.
Right.
Can you give me an example?
Absolutely. Let's say you're designing a new type of robotic arm. With CAD, you can create a 3D model of each component, see how they fit together, and even test different movements before you ever touch a physical piece of metal.
Okay, so that's CAD. What's next in the design process?
Now we move into the world of CAE, or computer-aided engineering. This is where we analyze how our designs will perform under real-world conditions.
Oh, so this is where you run those simulations, right?
Correct.
Tests and stuff like that?
Exactly. CAE software like SYS and Abacus allow engineers to simulate stress, heat fluid dynamics, and all sorts of other conditions.
So before you actually build anything, you can see how your design would hold up in the real world. That's pretty cool.
It's essential. It helps engineers catch potential problems early on, optimize their designs, and avoid costly mistakes. Want to register for MECHESOL's MESP Engineering Development Program to learn more? Visit mechesolco.com/CPD.
That makes sense. So we've got the design modeled in CAD and analyzed in CAE. What's the final step?
Bringing the design to life. That's where CAM comes in. Computer-aided manufacturing. It's the bridge between the digital world and the physical world.
Okay, I'm listening. Tell me more about CAM.
Imagine you've got this amazing CAD model of your robotic arm, but it's still just data on a computer CAM software like Mastercam and Fusion 360. Translate that data into instructions for CNC machines.
Way back up. What are CNC machines?
CNC stands for Computer Numerical Control. They're basically robots that can cut shape and assemble parts with incredible precision, all based on instructions from the CAM software.
So the CAM software is like a translator between your design and the machines that will build it.
Precisely. It's all about automation and precision, making sure those robots build your product exactly as you designed it.
Wow, it's amazing how these three types of software work together.
They're an engineer's dream team, allowing us to design, test, and manufacture increasingly complex products.
Okay, let's shift gears a little and delve deeper into a specific CAD program. SolidWorks. I know a lot of engineers use it. What makes it so special?
SolidWorks is super popular because it's user-friendly and incredibly powerful. It's got a ton of features that streamline the design process.
Cool. What are some of the must-know tools in SolidWorks that every engineer should have in their back pocket?
Well, everything starts with sketch tools. These are the building blocks of any design lines, rectangles, circles, arcs, you name it. They're what you use to create those initial 2D sketches that form the basis of your 3D models.
So it's like digital doodling, but way more precise.
Exactly. You're creating the blueprints for your design, and mastering these sketch tools is essential.
I'm starting to see how it all comes together. So you start with these 2D sketches, and then what?
This is where it gets really interesting. In SolidWorks, those 2D sketches are called base sketches, and they are the foundation of your entire 3D model.
So you extrude them or revolve them to create 3D shapes.
You got it. And as your design grows, it's super important to manage all those features and edits effectively. That's where the feature tree comes in.
I've heard about the feature tree. What's the big deal with that?
Think of it as a roadmap of your design process. It shows every step you've taken, every feature you've added, and how they all relate to each other. Keeping your feature tree organized is key to maintaining a clean and efficient design.
It sounds like it could get pretty messy if you don't stay on top of it.
It definitely can. But SolidWorks has some really cool features that help with that. Configurations, for example, are a lifesaver when you're designing multiple versions of the same product.
Configurations? I'm intrigued. Tell me more about them.
Let's say you're designing a chair that comes in different sizes. Instead of creating separate files for each size, you can use configurations to manage all those variations within a single file. It's all about efficiency and flexibility.
That's genius. So instead of having a bunch of separate files cluttering up your computer, you can keep everything neatly organized in one place.
Exactly. It saves a ton of time and makes it super easy to manage design changes and variations.
I can already see how powerful these tools are. It's like having an entire design studio at your fingertips. But learning all this stuff must take some serious effort, right?
It's definitely a journey, but it's so worth it. And there are tons of resources available to help you along the way. SolidWorks offers tutorials, online forums, and even certifications to validate your skills.
Certifications are like badges of honor in the engineering world, right? They show potential employers that you know your stuff.
They absolutely do. And speaking of showcasing your skills, building a killer portfolio is essential for any aspiring design engineer.
Okay, let's talk portfolios. What are your top tips for creating one that stands out?
First, focus on quality over quantity. Don't just throw every project you've ever worked on in there. Choose a few projects that really highlight your skills and make them shine.
So it's all about choosing your best work and presenting it in a way that grabs attention.
Exactly. Clear descriptions, high-quality images, and even animations can make your portfolio stand out from the crowd.
It's like telling a story with your designs, showing potential employers or clients what you're capable of.
Precisely. And don't forget to highlight the problem-solving skills you used in each project. That's what engineers are all about.
So it's not just about showing off pretty pictures, but also about demonstrating your ability to think critically and come up with innovative solutions.
Absolutely. And if you've worked on any collaborative projects, be sure to mention those as well. Teamwork is a crucial skill in engineering.
It's all about showing that you can not only design, but also communicate effectively and work well with others.
Right on. And speaking of collaboration and streamlining workflows, let's talk about BOM integration.
BOM integration, what's that all about?
BOM stands for Bill of Materials. It's essentially a list of every single part and material you need to build your product. And when your CAD system is integrated with your BOM management system, things get really efficient.
Okay, I can see how that would be helpful. Tell me more.
Imagine this. You're designing a complex assembly in SolidWorks. As you add parts and make changes, the software automatically updates the bill of materials, keeping track of everything you need.
So you don't have to manually update spreadsheets every time you make a change.
Exactly. It saves a ton of time and reduces the risk of errors. Plus, you can easily export the BOM in various formats for sharing with manufacturers and suppliers.
So it's like having a centralized hub for all your design and manufacturing data. Everyone's on the same page and everything's up to date.
Precisely. BOM integration is a game changer for streamlining the entire design and manufacturing process. Want to learn more about this? Visit mechesolco.com/CPD today.
This has been an awesome deep dive into the world of design tools. From sketching basic shapes to simulating real-world conditions and generating bill of materials, it's incredible how much power these programs put in the hands of engineers.
It truly is, and we've only just scratched the surface. There's a whole world of advanced tools and techniques waiting to be explored.
That's what makes engineering so exciting. There's always something new to learn and discover.
Exactly, and the more you learn, the more you can push the boundaries of what's possible. Are you ready to dive into some of the advanced features that SolidWorks has to offer?
Absolutely. I'm excited to see what else this software can do. What's first on the list?
Let's talk about sheet metal. SolidWorks has a dedicated set of tools specifically for designing sheet metal parts.
Okay, that makes sense. Sheet metal is used in so many products, from cars to appliances. What makes these tools so special?
They streamline the process of creating complex, folded shapes, automatically calculating bend allowances, and generating flat patterns that are ready for manufacturing.
Hold on, bend allowances. What are those?
Great question. When you bend a piece of sheet metal, the material on the outside of the bend stretches while the material on the inside compresses. The bend allowance is the amount of material you need to add to the flat pattern to account for this stretching and compression.
That makes sense. So the software does all those calculations for you.
Exactly. It takes the guesswork out of designing sheet metal parts, saving you a ton of time and ensuring accuracy. You can design anything from a simple bracket to a complex airplane fuselage with these tools.
That's amazing. What other advanced tools are there?
If you're designing structural frameworks like bridges or buildings, you'll love the Weldments toolset. It allows you to create and assemble structural members like beams and columns, generate cut lists, and even simulate the welding process itself.
Wow, so you can design and virtually weld an entire steel structure right there in SolidWorks.
Pretty much. It's a powerful tool for structural engineers. And speaking of simulating real-world conditions, remember those CAE tools we talked about earlier? SolidWorks has built-in simulation capabilities too.
So you don't always need a separate CAE program. You can run simulations right inside SolidWorks.
You got it. You can analyze your designs for stress deformation, heat transfer, fluid flow, and a whole lot more. It's like having a virtual testing lab built right into your CAD software.
That's so cool. You can test your designs before you even build them, saving time and money.
Precisely. And for those who are designing products that involve pipes, tubes, wires, or cables, there's the routing tool set.
Okay, so you could design the plumbing for a house or the wiring harness for a car in SolidWorks too.
Absolutely. The routing toolset lets you create complex routing paths, automatically route components around obstacles, and even generate bills of materials for all those pipes, tubes, and wires. It's a huge time saver.
I'm starting to think you can design anything with SolidWorks.
Well, it's definitely a versatile program, and we haven't even touched on CAM yet.
Oh, right. CAM, the bridge between design and manufacturing. What kind of CAM capabilities does SolidWorks have?
It's got a lot. You can generate tool paths for CNC machining, simulate the machining process to avoid collisions and errors, and even create G-code programs to control your CNC machines directly from SolidWorks.
Wait, G-code, what's that?
Think of it as the language that CNC machines understand. It's a set of instructions that tell the machine exactly what to do, where to move, how fast to cut, and what tools to use.
So SolidWorks can create those instructions for you based on your CAD model.
Exactly. It streamlines the entire process of going from design to manufacturing, ensuring accuracy and efficiency.
This is blowing my mind. SolidWorks is like an all-in-one design and manufacturing powerhouse. Is there anything it can't do?
Well, it's not a magic wand. You still need to understand the principles of design engineering and manufacturing to use these tools effectively. But SolidWorks gives you the power to bring your ideas to life in a way that was simply not possible before.
That's what's so exciting about engineering.
Yeah.
It's all about pushing the boundaries of what's possible. And speaking of pushing boundaries, you mentioned rendering and animation software earlier. How do those fit into the design process?
Rendering software lets you create photorealistic images of your designs, while animation software lets you create videos. They're great for presentations, marketing materials, and even for just visualizing your designs in a more engaging way.
So instead of just showing someone a static 3D model, you can create a stunning image or even an animation that brings your design to life.
Exactly. It's all about communication and presentation. Rendering and animation can help you get your ideas across more effectively and make your designs more appealing.
I can definitely see the value in that. It's like adding that extra polish to your work, making it really shine.
Precisely. And when you're ready to showcase all this amazing work you've done in SolidWorks, remember to build a stellar portfolio.
Right. The portfolio is like an engineer's resume showcasing their skills and experience. What are your top tips for creating a portfolio that impresses potential employers?
Focus on projects that demonstrate your problem-solving skills and your ability to think creatively. Highlight the challenges you faced and how you overcame them using SolidWorks.
So it's not just about listing the features you use, but about telling the story of how you use those features to solve real-world problems.
You got it. Make your portfolio a showcase of your engineering prowess.
That's great advice. And before we move on, I just want to remind everyone that if they're interested in learning more about SolidWorks and other design tools, they should definitely check out the MESP Engineering Development Program from MECHESOL.
Absolutely. It's a fantastic program that can help you take your engineering skills to the next level.
You can find all the details and apply at mechesolco.com/CPD. Don't miss out on this amazing opportunity.
Okay, so we've talked about, specific software and tools, but let's kind of zoom out and look at the bigger picture. Like, what's the real impact of all this, on how engineers work and the kind of products they can create?
Yeah, it's one thing to know how to use SolidWorks.
Yeah.
But how does that actually translate into benefits in the real world? Can you give me an example?
Sure. Think about designing a new type of wind turbine. In the past, engineers would have to rely heavily on physical prototypes and testing, which was expensive and time-consuming. Now, with tools like CAD CAE and CAM, they can design, simulate, and optimize the entire turbine, digitally reducing costs and speeding up development.
So these tools help engineers to work smarter, not harder.
Exactly, and that translates into better products. Because we can simulate real-world conditions virtually, we can create lighter, stronger, and more efficient designs.
That's awesome. It sounds like design tools are really pushing the boundaries of what's possible in engineering.
They absolutely are, and this is just the beginning. We're seeing incredible advancements in areas like generative design, where AI algorithms are helping engineers create innovative solutions that would have been impossible to imagine before.
Wow. AI designing products, that's mind-blowing.
It is, and it's just one example of how design tools are constantly evolving. For aspiring engineers, it's an incredibly exciting time to be entering the field.
I can only imagine. So for someone just starting out, what's the best way to get up to speed with all these tools and technologies?
Well, it can seem overwhelming at first, but there are so many resources available, online tutorials, university courses, and even dedicated training programs like the MESP Engineering Development Program from MECHESOL can provide a structured learning path.
Speaking of the MESP program, it's a great option for anyone who wants to gain hands-on experience with design tools and build portfolio of real-world projects. It's a great way to kickstart your engineering career.
Absolutely. And don't forget about certifications. Earning certifications in specific software like SolidWorks can demonstrate your expertise to potential employers and give you a competitive edge in the job market.
It's like a seal of approval that says, hey, I know my stuff.
Exactly. And the process of studying for those certifications will deepen your understanding of the software and help you develop valuable problem-solving skills. It's a win-win.
So we've covered a lot of ground today, from the basics of CAD, CAE, and CAM to advanced features and the impact of these tools on the engineering world. What's the key takeaway you want our listeners to remember?
Design tools are more than just software. They're powerful instruments that allow engineers to unleash their creativity, solve complex problems, and shape the future. By embracing these tools and continuously learning and growing, you can make a real difference in the world.
That's inspiring. So whether you're a seasoned engineer or just starting out, remember to embrace the power of design tools. They're the key to unlocking your engineering potential and making a lasting impact.
Couldn't have said it better myself.
Well, that wraps up another episode of Engineering Out Loud. Be sure to visit mechesolco.com/CPD for more information on the MESP Engineering Development Program and to apply. Thanks for joining us.